game is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello everyone and welcome to another meeting of the C++ Digital Signal Processing and JUCE study group. Though I think at this point we maybe should rename this because we are all going in different directions and not really studying JUCE, but it's definitely C++ and or C sound, but it's definitely digital signal processing, isn't it? At least that I think we can claim to be.
Of course. I still haven't written a single line of code.
Awesome. I have written some lines, but Siwitz has written a lot more. How are you doing, Siwitz?
Yeah.
Do you think I have written a lot more lines than you?
Absolutely.
That would be great, but for past month I more procrastinating than doing something, and from couple things, neither writing code. So yeah.
I find that this process of procrastinating is when you are in the middle of it, you are like, oh man, I feel bad about myself. But then after you're done, there are some things that you look back and you say, oh, I wouldn't have known this or that if I wasn't procrastinating, reading these things or watching those videos and maybe just walking outside and having ideas. So I find that it's part of the process. And I used to beat myself up when I was procrastinating. These days I just embrace the fact that we are not machines.
Exactly.
Yes,
we need
and
the time to do it, Charles.
Of course, especially if you done in 3 months big work and then you have to rest sometime.
Yep. So
this is not so easy.
Absolutely, yeah. And I have been working on the thing that I promised I would be working on, but ever so slightly. So I don't have a lot to share, but I thought I would go first today because I usually go last. So I'm going to share with you what I did and what I learned. So the main challenge was my auto mixer has to have access to multiple tracks of audio at once. And in most digital audio workstations, that can be weird because there is no flexibility in terms of routing. You have bus tracks, but all of the signals that go to the bus are mixed together before the effects have access to them. And then in my JS Effects version of the auto mixer in Reaper, the solution was to just use the Reaper tracks and the flexibility that they have in terms of having multiple channels, and you can route any channel to any other channel. And that works. But if I want to make a C++ version that will work in any DAW, I'll have to do that trick of having one instance of the plugin per track. And those instances will be running in send mode. And then there will be another instance of the plugin running in receive mode on the bus. And then it will have access to all the audio's tracks individually, so that it can compute the gain and attenuation for each track individually. And I had this question.
Like a server and the clients?
Yes, something like that. And there are effects that have a similar problem, and they end up having a similar solution. So, for instance, there are these plugins that are supposed to simulate what happens on a mixing desk when you're mixing channels together, which is analog mixing, which may not be exactly the same as just adding up the signals. There are some nonlinearities in the process. And I guess, Fotis, you probably know about this, right?
Mm-hmm.
Yeah, you probably have used or at least played with some of the Air Windows plugins that do this, right? The console plugins.
And just like Aria says of IDDQD sound, he says analog schmonalog.
So you don't think that this is super useful? You don't hear a lot of difference?
No, I do. It's Aria who doesn't care about analog hardware, I think. But yeah,
Okay.
I really like I like analog saturation, not necessarily because it's realistic or close to the real thing, but because I like the way it sounds dirty and not boring.
I
It gives
see.
a little bit of spice.
Well, to be honest, I have never played with these kinds of effects, so I don't know how well they work in terms of the quality of the sound that comes out. But I do know that the architecture, as far as I understand, works like this. So there are several versions here, but let's use this one, the purest console. And then we have one instance of the plugin per channel.
Mm-hmm.
And then we have one instance of the plugin running in bus mode on the parent. And you can see that they don't even have controls because they don't need. They're just sending audio from here and getting audio there and then mixing everything up, and they're doing that in an analog way. So it is adding the artifacts of, or at least pretending to add the artifacts of an analog console. The problem that I have is similar. I have to send audio from all these tracks and receive here, and I need access to the audio sources individually. My question was, what happens if I have some other plugins on one of the tracks? And so if I have different plugin chains on the different tracks.
Yeah.
And more specifically, what happens if one of the plugin chains adds latency while the other doesn't? So I came up with this experiment. I will show you what I'll show you the experiment, and I will show you the results. So the experiment goes like this. First, I have a similar scenario here. These are not 3 children tracks. This is one child track that is just producing a tone. And then I send, not to the parent. You can see that the cyan bar here is not enabled. So it's not sending to the parent. It is just routing this audio to these other 2 children. And then on this child, on this one, and on this one, I have 2 instances of this plugin that I created in JSFX because I was cutting corners. So I created these plugins in JSFX, and what they do is they are the auto mixer latency test in send mode. So this one is sending to the parent in track 1, and this is sending to the parent in track 2. And as you can see, track 2 also has another effect here that I called, very aptly named, test. And what this one does is it introduces latency by an arbitrary amount, but it also reports the latency that it introduces. So it's a simple delay, but it reports the plugin delay so that Reaper can compensate for that. And then on the parent, I have another auto mixer latency test, this one in receive mode. And what it does is just add up all the children. And then if I have no latency, well, I did something else actually. There is a little trick here in the middle. When I was sending to the second child, I flipped the polarity. So if I add everything up, it should null. And it does.
Yeah.
You can see that there is no audio coming through here. Naturally, if I mute one of the 2 tracks, then audio starts popping up here. So they're nulling perfectly. And if I mute the other one, audio starts popping up there as well. So everything is right. Then, then the question is, what happens when a plugin has some latency? Are they going to be out of sync? And then that would be bad, right? If I'm trying to mix stuff, but they are out of sync, that's bad. So what's your guess? Do you think that it's going to be in sync or out of sync?
They're going to be out of sync.
Yeah,
Because they're not nulling.
That's what I thought too. And check this out. Yes, they go out of sync.
Yeah.
So that's to be expected. And maybe there are ways to work around this by going to different plugging delay compensation modes. This is compensating per chain. Maybe there are variations here that could fix this, but then it would be Reaper specific, kind of defeating the point. So I think that the answer will be that the sender can introduce some latency if you want. So as an advanced kind of thing, if you have different plugin chains on different tracks, then the sender can have a latency to sync everything up. And then, of course, here I have a latency of 9,412 samples. So on the other one, I will need to add 9,412 samples to compensate. And I expect that this is going to be an edge case. Most people are not going to care about this. Most people are not even going to run into the issue in the first place. And even if they run into the issue, probably the latency of the plugins is going to be so small that it won't matter. Because we are thinking of a case where we have multiple microphones in the same room. And in that case, there will already be some latency of the physical space of the person speaking and the bleed getting into the other microphone. So there is already some latency in the process. So if they drift out of sync ever so slightly, that's fine. Probably 9,000 samples would be too much, but if most plugins will introduce, a couple hundred samples at most. So it will probably be fine. And it's probably an edge case that most people are not going to run into. I won't worry about this too much, but I wanted to know what I was doing. I wanted to know if this would be a problem or not. And even if I decide not to include this latency thing, because it could be complicated to explain and people could get confused by that, at least now I know what the limitations of the system are if someone complains about that. And
I have two questions.
Yeah.
Are you finished? Okay.
Yep.
The first question is, you have all the Air Windows plugins installed, right?
Yeah.
There is one called C-Strip. It's a channel strip plugin, and it has a feature called time lag. And I think that's similar to what you did. I think it introduces latency.
Let's see. Yeah, it seems to introduce latency, but it doesn't report the latency.
Oh.
Which in most cases is what you want. Because in most cases, and there are other plugins like this. There is something by Voxengo, forget the name of it, latency delay.
Corralometer on latency. Oh.
Yeah, this guy. And it's already introducing 10,000 samples worth of delay, even if I don't set anything. Yeah, so it's not doing exactly what I did. Because in most cases, when you introduce latency, it is because you want to sync things up, so you don't want to report that latency to the host, otherwise your syncing will go out of sync again. So that's why I had to come up with this weird situation here where I don't think this plugin is useful for anything besides this test, because it introduces latency and reports that latency, and the host is going to compensate for that.
And my other question is, I almost forgot. Yes, not about latency. Oh God, my mind went blank for a second. About the auto mixer. Yes, you did this test with latency. Now you should do another test about potential phasing issues, because when you're summing audio, when you're summing audio from multiple microphones, you have crosstalk, you have all sorts of weird phasing that occurs when a sound is coupled together from two different sources. And I was wondering if you had some kind of a workaround for that, if you could implement, I don't know, some kind of phase rotator inside the auto mixer.
That's an interesting idea. I haven't really thought about that. The basics, I think, would be to do latency. I could just delay some of the signals so that they don't cancel as much. The other simple thing to do would be to just flip the polarity on the sends, just like I did when I was routing the audio with this little button here. So those are the low-hanging fruits. Phase rotation is also a nice idea. I may play around with that. But I guess in general, I did all these experiments just to be able to say, okay, I understand that the problem exists, and now let's ignore the problem and continue doing the thing. Yeah, that's a good point. And I think there's something else that I will briefly mention that is kind of weird. And that is, so forget about this whole flip polarity and trying to sync everything up. So just check this out. I have a tone generator here sitting there. No delays, no nothing. And the parent. It's going to work on a single track. And I'm going to show you the source code for this plugin because the source code is just 2 lines of code. I set this global space in memory, and this global space is visible by all instances of the plugin that declare the same name. So both the sender and the receiver will have the same name. And then I go into this global space and I write a single sample in there. Okay, so far so good. This is the sender.
Okay.
Now the receiver is just, I actually showed you this before, it's just what you would expect. It is just looking into the same place and adding everything up. And it starts with a 0 and it adds up all the tracks. Currently there's only 1. So this is just putting a sample into the global namespace, and this is getting a sample from the global namespace and then producing that. I was expecting that this simple arrangement would work and that there would be no difference. But can you can see the difference actually. So here is the tone generator that is just sending the audio, and it is completely flat here. And on this one, you can sort of see it flickering. And if you hear this, you will be able to hear the difference. Let me make sure that we all can hear this by sending to the computer. So now you are only going to hear this guy, and this was supposed to be a sine wave. This is not a sine wave.
Interesting.
So there
It sounds like a saw wave.
It does, and it. One thing that we can do to investigate this is put an oscilloscope there. But I think that the thing is, this doesn't look like a sine wave.
Yeah.
So that probably there is some sort of race condition going on. I don't really understand because this is the original signal I'm sending, and this is what I'm receiving. So these two don't look the same. When I did my original automixer, I didn't run into this issue because I wasn't using the global namespace this way. But it seems like using the namespace this way is not exactly the solution. There seems to be some kind of race condition in between the sender and the receiver. I thought that the execution model would be each children, as long as they are independent, each child runs independently, and then when all of them are done, the parent will run. So the senders would have completed by that point. Doesn't seem to be the case. There is some sort of race condition, so I guess the solution will be in this global namespace. I don't want to store just one sample for each track. I probably want to store a small buffer of samples, and then I will have some space to play as one is writing and the other one is reading. So yeah, that concludes my part of the exploration. That's what I did these 2 weeks. Who wants to go next?
I have one question also.
Yeah, go ahead.
Related to the delay example. What will be if the delay will be equal to the Nyquist frequency of your DAW, or half of it?
Well, I guess a delay of 48,000 samples, for instance, right? Or 24,000 samples, something like that.
Then, if you have flipped phase, then on the parent track there should be also not noise but opposite, silent. Am I right?
You mean in the original experiment that I had?
Yes. Can we try it?
Yes, I think you are right, and we can play with that. Yes, I just have to come here to recent projects and open this, but not save. And then here we are with the original setup. And then what they're saying is that on my latency thing, right now it's 0. If I put an arbitrary value, we start seeing some samples peeking in. And at 24,000, it cancels out. No, but there are some values for which it cancels out, I think. Yeah, we can see the meters going up and down as I change, and the two waves interact in destructive ways.
It's also something similar that 40 said about phase, I think.
Oh.
Because in general, you're moving the phase of the original signals.
Yep. Yep, you do make a good point. How can I get this to cancel out completely? I don't know what values I need to put here, but I think there will be values for which this will just cancel out.
Okay, do you have the Nyquist frequency 48K, yes?
No, the Nyquist frequency in my machine is going to be 24 because my sampling rate is 48.
Yeah. But then why at 48 it's not canceling?
Well, the polarity is also flipped. Oh, but this number shouldn't be related to the Nyquist frequency. It should be related to the frequency of the tone. Let's make this number 1,000. And then we know that it will be 1,000th of a second. So it will be 48,000 divided by 1,000, which is 48 samples. No, doesn't seem to work. Well, whatever. I think that there are values that will make this cancel out.
Yes, of course. Just interesting.
All right, I'm dying here, so I think this concludes my part of the progress. Who wants to take over?
See, which do you want to do the honors?
I can try.
Thanks.
I have to share screen, yes.
Yeah, you can share your screen and I'll put it up here.
There will be not much interesting things, but still. Yeah, so for... I have to run my thing. Oh. Forget, I have to recompile this. For past week, I have... What? There was an error? What? Sorry. I have managed to my sampler shift the pitch of the sound. It was, in theory, it was not really hard to do, but for me it was a little bit hard, but I can try to... Oops, sorry. I can try to show you some sound examples. You want to hear something? Yes, I got run into a couple of problems. I don't know why. For example, now it's not loading the sound. Oh, here it. Do you hear something?
Yes.
I can do a little bit louder. Oh,
Mm-hmm. We hear that.
So this is the original, how it's supposed to sound. I can do something. Yay, and it works.
And how are you doing that?
Yeah, there is no big problem. 1 second. I have, yes, experimented with some of FFTs. I was able to see magnitudes, the phases, but I didn't manage to get the real frequencies of the sound. But looks like something similar that we was seeing in the cool FFT stuff. I don't know. So yeah, for sample, I have to play every voice separately. And for example, if I have many of voices, I have to.
So you were experimenting with FFTs, but that's not the implementation that is actually running.
Yeah.
Are you
Yes.
doing it? I don't know if you watched our stream with Arya recently, but we were working on a pitch shifter and we implemented it in the simplest way possible, which is to just buffer some samples and then play them back faster to have a higher pitch, or more slowly to lower the pitch. Is that what you're doing?
I have seen the little bit of your stream, yes, but I didn't see it fully. But yeah, I'm doing here I think the same thing. So I have root pitch and the original pitch of the sound and divide them, then have pitch factor and calculate the amount of samples I have to read to change the pitch of the sound. And then in a loop, I'm reading for that amount of samples to the temporary buffer. And then I have another loop where I depend on the pitch. I'm making the actual buffers of the sound by placing the first sample of as it is, and making the second sample from the sum of two samples and divided by 2. Something like that, yes.
I see. And are you doing this processing in real time, or are you just working with samples on disk?
Sorry, what?
Are you doing this as a real-time processing thing, or are you just working with samples that are stored in disk?
What do you mean by the real time? Like I can connect microphone and
Exactly.
speak and first of all, I don't have microphone input on my Raspberry Pi for now. I have ordered analog to digital converter, but it's still coming to me. So in the future, I think yes.
Okay.
But for now, I'm working with the samples from the memory.
I see. Okay. Yeah, so you don't run into many of the issues that we ran into when we were implementing our pitch shifter, because in our case, we were doing real-time processing. So if you want to play the buffer twice as fast, well, how can you do that in real time? We cannot look into the future. So we have to buffer and then we have to wrap around and all sorts of issues that you don't necessarily run into when you have the full sample that you want to pitch shift.
I think there can help the FFT things. There is in the internet, I can try to find and share a link where one person implemented some FFT pitch shifting.
Mm-hmm.
And maybe it will be helpful for you.
Yeah, sure, absolutely. If you find that, share with us. And I know that there are other techniques too. Of course, there are more interesting and sophisticated techniques to do pitch shifting. Some of them try to preserve the formants so you don't sound like a chipmunk when you pitch shift up and that sort of thing.
Yes, but this is the simplest way of pitch shifting, how I understand, and there is a couple artifacts in the sound. I don't know how to get rid of them for now. For example, now you can't hear, but if I plug my headphones in the output, I can hear some cracks, some weird noises, and other things. And also, I have run into a couple of problems with my Raspberry. For example, one problem is that I can't do sound buffer less than 1024.
Why is that?
I assume that this is because digital to analog converter that is built into Raspberry Pi is running through the GPU, and there is some limitations. So I also have ordered the external analog digital to analog converter that I in the future can try to plug it in and get everything works fine. But also I ran into problem that reading the sample in this thread of the audio processing thread and reading samples from the push thread to draw GUI, graphical user interface, are somehow affects this piece of code, somehow affects each other. And as you can see, there is two different threads that are consuming similar CPU usage, and I don't know how to get rid of them. If I, for example, play many voices in my sample, it starts to doing these weird things.
It wasn't supposed to sound like that?
No, it wasn't supposed to sound like that.
Because it sounded cool.
Are you sure?
Yeah,
It's a problem with latency.
No, just the CPU usage is more than 100 and it cannot process.
But the CPU usage being more than 100 isn't an issue. Your Raspberry Pi seems to have 4 cores.
But I don't know how to split it properly for now.
Well, if a process is taking more than 100% CPU, it means that it's just spreading across multiple cores. Because you cannot have more than 100% CPU in a single core.
Yes. It should sound like something like this.
Ah.
But if I make it starts lagging.
And if you increase the buffer size even further, I know that 1024 is already a big buffer, but if you go even beyond that, does it help?
4096.
I didn't try it. We can try this.
Is Visual Studio Code running in the Raspberry Pi, or is it connecting remotely?
I'm connecting remotely using SSH.
I see. Okay, yeah, there it is.
But it's doing things. Oh no, I have to not this, but How big buffer? 4086? Is it power of 2?
It is correct, 4096.
Also, I have another problem that if I play many voices, then I have to delete them properly. But for now, I have the problem that if, for example, I play one voice with lower pitch and one voice with higher pitch, then that voice that stops playing, that finished playing, it deletes the first voice that has lower pitch. Maybe I should move away from array of voice and use the vector of voices. Maybe I didn't try it, but for now I have the circular buffer with the tail and head and the number of voices playing. I think I have to
So the
change
way it
that.
works is every time that you play a note, it allocates a voice, and then when the voice is completely decayed, it deallocates that voice and allocates a new one.
For now, it's not allocating the new things. It's not working like a pointer. As you see, the here is no pointer, like something this is. But it allocates the array like a standard C array. Yeah, for example, something like this, but in the STL container called array. And all voices are allocated there. What I'm doing, I'm just writing in the proper voice position all the things I have to know about that voice. The file pointer, the start position, end position, pitch, velocity. I didn't use this thing for now, but maybe. And then increment the head of the circular buffer, and of course the voice is currently playing. And when it finished, is it? I don't know how to correctly playing. I'm clearing that voice out and moving buffer the some weird thing.
I see, but there is a fixed from the beginning. There is a fixed number of voices, or a maximum number of voices that can be played.
Yes.
Okay, yeah, that's what I thought.
64.
Yeah, before I have misunderstood, thinking that maybe you would have allocation and deallocation of voices happening while the person was playing, and that's probably not a good idea. But you're doing the thing that I think is the smartest idea, which is just have a pool of voices and then taking voices from the pool as people play keys.
Yes, it will be little bit faster in the processing thing, in my opinion. But yes, but this code working somehow weird little bit, and I have to try obviously to do this thing in the vector neither than in array. But yeah, so we're now at the 4000 buffer. We can let's take another. Oh, and there is funny thing. If I if I switch the file while it playing, it keeps playing. For example, here's the one. I will load another, and it keeps playing. It's not stopping. Even if I have switched to completely different file, it keeps playing the previous file that has been unloaded. I don't know why it's doing like this.
But it's actually a good idea, isn't it? When you are playing and you switch to a different sample, I think that the nodes you have already played should continue with the old sample, and the nodes that you are going to play later are going to use the new sample, right?
I think really the opposite, that it hasn't been like this. It just have to stop the playing and just erase the file and load the new one.
Oh, all right.
But it's not doing like this. I don't know why, but it's really funny. So what be if I will play many voices at the time with this big buffer? Let's do some mystic. Yeah, we can't understand. So have to check. Page stop.
Sorry, I will be back in 5 minutes, okay?
Okay.
For now, it's like a 16 voices maximum playing. There is yes.
This doesn't sound right.
Some weird happening. Yes, of course, this doesn't sound right. But I think, yes, that this is because I am reading from the same memory address from both threads. For playing and for drawing this waveform on the push display here.
Yeah, I have run into many issues related to concurrency and drawing waveforms. There's now like 1,000 streams, 1,000 coding sessions of me trying to figure everything out. I think that the best way to go about this is, if you need to display waveforms, write to a separate circular buffer that is dedicated to communicating between the audio thread collecting the samples and the UI thread displaying the samples. You want to separate that from everything else that is happening on the system. Maybe it is not ideal because it uses more memory, but it's the best way to sync everything up, I find.
Yeah, I totally agree you. And the things that I become too is for example, Reaper and Ableton, and I think the other DAWs uses peak files.
Yes.
And maybe this is the decision of my problem, but how to make that peak files? For example, Reaper for 8 megabyte WAV file making 7 kilobytes peak file.
Yeah, I think that I have never investigated this deeply, but I think that what they do is just go over the WAV file, collecting the maximum and the minimum in blocks, and then storing those numbers so that later you can just plot the maximum and the minimum for the samples moving forward.
Yes, something in the same way that it's
exactly
done here. But if I just will be doing this and saving to the other file, it will be the same 8 megabytes of the sound like in a original file, no?
No, you
Because-
just do it in Windows. So like take the maximum and the minimum from your samples in like 1,000 samples, let's say, and store the maximum and the minimum of 1,000 samples. That way you are going to be reducing the file size by 1,000.
I'm back.
Hello.
But why I should do the only 1,000 samples?
Well,
I
because
want
on
to
the
draw
display, you won't have the screen size to show each sample. You will only have the screen size to show, like, each pixel on the screen corresponds to 1,000 samples in this example. Of course, you
Yes.
have to compute what the exact numbers will be, but what I'm saying is that there is like 1,000 samples per pixel, so you store the maximum and the minimum of 1,000 samples. And then you will be able to draw a column on that pixel.
That's right, but I'm also want to zoom in or zoom out across the audio file.
Yeah, and I think that if you want to do that arbitrarily, if you want to be able to zoom all the way in until you see each sample individually, you will have to have different modes of operation. You look into the pix file up to some zoom size. After that, you have to go into the original WAV file and look there. But you'll be looking at a small window, so it will be okay.
And then like rearranging that big file, yes?
Yeah, you have to seek into the big file to find the portion that you want to display.
It can work. Good idea, thank you.
Yeah, sure. Anything else that you want to share?
I don't know. I have started also making some tries to save and load things,
Okay.
but for now I breaked everything up because I have added a couple others.
I see. And when you
Things-
say store, you mean like storing settings and presets, that kind of thing?
Yes. For example, I also have made a simple sine wave generator that I can play around with. Oh, here it is. Yeah, I can play some music.
Are these samples or tone generators?
This is tone generator,
Oh, nice.
which makes one second. Oh, here I'm using the vector of voices. Basically acting in the same way like a sampler. I have some voice class, but here I have vector of voices, and it's working, I think, better. I'm not sure, but yeah, I have here the simple syn function
Mm-hmm.
that is generating the 440 hertz tone. Yay. Something like that.
Sure. All right.
Not
And
as-
what are your plans for the next meeting?
Ooh. For the next meeting, I want to make some simplified MIDI editor
Ooh.
I think I want to start digging in that kind of things. So I yesterday have started something, and basically I can open the MIDI file, but just open and dump all the things there is. Here's the all things saved in MIDI file in this one. There is just two notes, yes, of the, but it working for now. We will see what will be in the future.
Okay.
But yes,
And the reading of the MIDI file is something that you are doing yourself, or are you using that library?
I will try to do myself
Okay.
this thing. Of course, with the little help of Google and there's some snippets from the internet, but in general, yes.
Yeah, sure. I think that to begin with, it will be relatively manageable. Maybe if you want to support all kinds of MIDI messages, it gets a bit weirder. But the basics, it's an old protocol, and old protocols tend to be relatively straightforward.
Yes, that's the point.
Hmm.
I wanted to ask a question since you mentioned the word protocol, something popped in my head. Seaweeds and Leandro, have you guys heard of OSC, Open Sound Control?
Yeah.
Yes, Reaper are using it, and I have a couple times played with it. Especially, there is couple applications for Android and iOS that
Yeah.
can act as a MIDI controllers through Wi-Fi. It was pretty interesting experience. But
Yeah, I want to ask about whether OSC can actually be used as a replacement to MIDI. I mean, you can
I
transport
think
notes
so.
via
I think so.
because
It's mostly for control surfaces. It's mostly for like what you would do with CC messages in MIDI. But maybe you are able to transport notes as well, because as far as I understand, the OSC protocol is open-ended. You can come up with any kind of message and send that through the wires. So as long as the receiver understands whatever is that you are sending as a note, it should work.
the thing is that MIDI is changing. They're doing MIDI 2.0, they're doing MPE and all those stuff. And it will be interesting to see how you implement this in OSC because this is getting a bit weird. But I saw a meme once, an animated GIF that showed two little guys. The one guy is called MIDI and the other guy is called OSC. And the OSC guy is pulling a gun and is killing the MIDI guy. And then it says the end. So
I don't think it's like that. I think that MIDI will be around for the longest time because of backwards
Yeah.
compatibility.
Also, I wanted to share some stuff. Did you have anything else to say, Sweet, about your project?
yes, Leandro, the second link is that pitch shifting technique using FFT. I think it can help you with Aurea developing.
Let's see if I can sort of understand what's going on here.
These guys are Synaptic, the company. They have made a pitch shifter that's called Pitch Map, and it's very interesting, but it's very expensive. But yeah, I would think their plugins are very beautiful, like this one.
Wow, this is an old article.
To be sure, I have tried a couple times to implement this speech shifter in my previous experiments with the code, but I failed.
Interesting. The beauty of the approach that we are taking is that it's so simple. It's so straightforward. Just play the same thing faster. And yeah, there's all sorts of issues with that, but it's so simple. You can implement that with 100 lines of code, more or less. While this is probably going to be a bit more complicated, but I will look into it.
There is code snippet also in the C language.
Yeah, I saw that. I will look into that.
Speaking of pitch shifters, another thing is this one. This is a company that is selling sample libraries, but they are not using Contact or something like that. They have made their own technology, and it's called Synchronous Waves Acoustic Modeling, or SWAM for short. And they are calling it multi-vector / phase synchronous sample morphing technique. Yeah, they're
Of
not.
course.
Oh, yeah, exactly. Obviously, they're not going deep into that because it's their baby. They don't want to say how they are doing it because somebody may try to reverse engineer it. But the way I understand it from this multi-vector thing, I think maybe they're essentially bending and pitch bending the waveforms as if they were vector graphics. Maybe I'm wrong, but that's what I'm getting from there. And I was thinking maybe a pitch shifter could work in that way. I don't know.
I wouldn't know, but I will look into that.
Yeah. And also, I wanted to share a few other things. Well, I didn't work on a plugin myself. I spent last week beta testing for a friend of mine that's called Aaron. He has Stagecraft software. This is the site. You've probably heard of them. They're pretty popular plugins, and they recently made a new plugin called Disarray, and I beta tested for that. I made sure because the first version had a few problems in Reaper. And the plugin is right here. You can get it for free actually for a couple of, I think until April 18th. And it's an XY modulator. It allows you to modulate any parameters from any plugin in an XY space, like Ableton or a Chaos Pad. And it also comes with some effects.
How can you control from a plugin? How can you control parameters on another plugin? You have to go through the host somehow, right? You have to write some automation on the host, and then the host has to link that automation to the other parameter on the other plugin.
Yeah,
okay.
I didn't. And also, you can do it with Reaper with parameter modulation. If you link, I'll show you an example. You don't have any. Oh yeah, the tone generator that you created once. I think it's the oscillator. Yes. If you go to a plugin and click the param button in Reaper.
Yeah, I can show people how to do that if they don't know.
Okay.
So any kind of plugin, let's think about a plugin that can be fun. A wah pedal. You can get here the position and then parameter modulation with an LFO, and then the wah turned into an auto wah.
Yeah, but there is a third option below the LFO one that allows you to link parameter from an external plugin. And this is where all the fun begins. I also found a pretty neat JSFX that's not in Repack. It's in the Stash. Hold on a second. It's made by Ashcat. Sorry. You go to ash.reaper.fm, and I'm going to send you the link to the script.
Yeah, but before we talk about that, this notion of linking parameters is what Reaper gives you out of the box, and this plugin is creating that for any DAW, right?
Yeah, exactly.
Okay. Interesting.
And it was made in JUCE, and it does have its plugin loader, so it can work as a plugin host.
Oh, it can. Oh, I see. So you load plugins into this guy, and then you control the plugins that are loaded in here. You cannot control plugins that are in the plugin chain. So if I have, suppose that this plugin is here is the wah-wah, and I have an EQ next to that, there is no way for me to control using this plugin, this instance of EQ.
No, I just think that if you can ask Aaron, I can ask him.
Okay, that makes more sense. So then it becomes like a meta plugin kind of thing.
Yeah, like a beta plugin, yeah.
Nice.
The other thing I wanted to show...
nice in some ways and not so nice in other ways. For instance, you probably cannot load re-EQ in there because re-EQ is only loadable in Reaper. So I guess not even if you are in Reaper, it won't be able to find re-EQ because re-EQ doesn't present itself as a VST on the file system.
Actually, it does. There is a VST version of re-EQ in the re-plugs.
Oh yeah, that is Windows only, hasn't been updated for 6 years. But yeah, there is an old version of re-EQ that will work on some Windows machines. Yes.
Yeah. And also that upcoming plugin that's called YSFX. I used the beta version and it's very heavy, but it can load a lot of JSFX that read.js can't read. And I've been following its development. Now, the other thing I wanted to ask Seaweeds as well about this. This plugin, a GitHub repository called Guitar ML. That's about open source amplification of guitars using machine learning. And they have this thing, if you scroll down, that's called Neural Pi. And basically what they're trying to do is turn a Raspberry Pi into a guitar pedal. And below you can also find a smart guitar pedal. They have lots of stuff.
Very nice.
So yeah.
I can tell that this was built in JUCE.
Yeah, this is the default stuff.
Yeah.
But yeah, I want to ask Sigwitz if you could consider implementing some of these effects in your Raspberry Pi sampler. Like you could distort a sample with guitar distortion like the one these guys are using here.
With the neural networks?
Yeah, or maybe just with the impulse responses that they have. You don't have to use actual neural networks. They have some ready-made stuff.
I don't know so far to be true. But well, why not?
Mm-hmm. Yeah, you can try.
If at that time I will continue my project, then why not?
I am really interested in knowing if machine learning helps or if it's just like a cool trick, because you can get very far in terms of emulation by just looking at the outputs of something and writing mathematical models that approximate that. Next, you can do some analog modeling. So for instance, they have here the Tube Screamer emulation. It's not really an emulation, but it's a clone, I guess. Mm-hmm. You can try to do emulations by looking at the internal circuits and then modeling that. But they are using something else entirely. They are kind of combining the two approaches in some ways because they are using machine learning based on the inputs and outputs that were given to the pedal. So I wonder if it is better because, for one thing, it's probably going to be slower. It's my guess. My guess is that if you have my guess is that if you have a simple formula that sort of approximates what's going on, that's probably going to be the fastest. Then to try to emulate every component in the circuit is probably going to be a bit slower. And machine learning is going to be around the ballpark of simulating every component. So I wonder if it's worth the processing and maybe even the latency that
sometimes it is worth it. It depends on how they implement it. For example, one of the most impressive use of machine learning in plugins that I have heard is from a company called Baby Audio. They made a plugin that's a tape simulator called Tape with AI, TAIP. And I have used a lot of those cassette tape-like emulators. And this one is crazy how it sounds. It doesn't sound like a plugin. It does sound dirty. Yeah, that's the one. And they said that the way that they did it is because all this time that we have been making analog simulation plugins, we are trying to approximate how a machine works, like a console or a tape machine or something like that. But in this case, Baby Audio didn't get into specifics, but the gist is that they tried to make the machine learning think like a tape machine. Like they went to high level stuff. They tried to.
And that sounds very sci-fi and vague.
Yeah. And one last thing that I wanted to show. Yeah, I sent it on the chat. It's a Lua script for Reaper, but it gave me an idea, and I think that's what I'm going to do for the second part, for the next, in 2 weeks, what I'm going to do. So this thing is called Lil Mixing Homie. It's basically a little helping plugin that you assign a keyboard shortcut. I used the T key because I don't use it in anything else. So you hover your mouse over a waveform and it pops up this little window and it allows you to pan, gain, mix, mute, and solo. And it sounds like it's something that's superfluous, but I like its simplicity and the way that it gives you all the little options with so little mouse movement. It gives you all of those in a tiny, concentrated space. And
interesting.
So the thing is that because I want to contribute something to this project, but I still haven't been into the right mindset to code, I was thinking, since I am a graphic designer, I was thinking of doing it the other way around. I would actually prototype a GUI of sorts for plugins so I could determine what I really want from DSP and then look at how I would code this. So basically, I'm going to draw the plugin that I would need because I still need to put this down on paper to make sure what I really want to make. And then ask you guys, the pros, for coding help.
That's a nice idea. I find that the most difficult part is finding the sliders that you want to have and how to calibrate them and how you want to organize the user interface so that people can make sense of what's going on. So if you start with that, I think that you are off to a good start.
Thanks, because I have used so many plugins, both free and paid. And I think I have gone to a point where I know what the customer wants. I know what design choices work and which don't, which colors, fonts, and all that stuff. So I think I have a pretty good grasp of what makes a plugin look good. And I have made one plugin, remember? It is a sampler plugin, but we did lots of tests and I learned some stuff from there. So yeah, and I could design the second version of the drum plugin that I would like to make. Oh, and this is a highly advanced topic, but it's another thing that I would like us to discuss in the next meeting, if you don't mind. It's kind of similar to what I showed you earlier with that multi-vector blah 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 thing. I've seen that a lot of plugin companies are going to a different route with instrument plugins, because all this time we've had contact, we had all those sample stuff, and then a bunch of scripts that are above them with the mappings, key switches, effects, etc. But now I've seen that the plugin developers are moving towards a newer way of making sampler instruments, in that they are combining both sample playback and sound synthesis. This is called hybrid sound. Like IK Multimedia was one of the first to do it because they made Syntronic, but now I see they have also made a pretty nice drum plugin called Modo Drum, which combines samples of real drums and also a little bit of synthesis that makes the samples just a little bit more real. It gives a little bit of extra randomness that you can't achieve with regular samples, even if you record 1,000 round robins. And I think that the era of making 1,000 terabytes of samples for a library, I think that era is slowly fading away, and we're going towards a new era where we're going to create unlimited sounds with just a few samples and a good sound synthesis engine. Also, Sample Sound is doing that too. It's faking round robins to create electric piano sounds.
So you would train a machine learning algorithm to learn what a kick sounds like, and then you ask the algorithm, can you give me a new kick?
That would be awesome. I would actually train a machine learning to create a drum space, like a warehouse or a studio.
Nice.
And that's where your auto mixer could come in handy, because you know that a drum set needs a lot of microphones, you know? So you will need an auto mixer for that. Sorry? No? Okay. So,
yeah, the auto mixer I don't think would work very well for this setting, because in a drum set you do want to hear every microphone, and yes, they're spilling into the other microphones and whatnot, but I don't know, maybe, I don't know if people have tried this, because the auto mixer is nothing new. I guess it has been around for 50 years at this point or something like that. So I wonder if people used it for other purposes besides just multiple microphones with multiple people speaking on a round table kind of setting. Yeah, it could be interesting. Bo is giving you a high five because he's also a graphic designer.
Hey, Bo. Oh, and you reminded me of something else. Sorry. I was researching ambisonic and binaural stuff, and you said about something about people in a room talking and using an auto mixer. I saw a company that's called Sofa, I think that's called what they called it. They're trying to implement a feature that when you're listening to a group meeting like a Zoom or something like that, not a Zoom, but a place where people are in the same place, that was obviously invented before the coronavirus. But anyway, they were trying to implement binaural sound into a press conference, so that you could hear each person individually, and you could rotate the 3D space so you can never miss something. Or if you don't like a specific person, you can mute him.
That sounds very uncanny valley kind of thing, because you'll be hearing everyone in a different space, and maybe you would have a VR set, and then that would be very weird. Yeah,
but I was thinking about whether an auto mixer could be useful in these kinds of things, like in a press conference or even a political.
Well, now that you mentioned this,
talking.
in
Yeah.
my version of the Automixer, there is this notion of strength. And the reason why I implemented that, no, not the notion of strength. There is the notion of priority. Strength is a different thing. But the priority is just, suppose that there is a moderator on the round table and you want the moderator to duck everyone else when they're speaking. And if things get heated. So you could just use that feature and you know where you are in this VR setting. So you could just use the priorities to increase the priority of whoever is near you and decrease the priority of people who are further away. So it kind of simulates what happens in a real space, which is kind of nice. All right, so I think I didn't answer it myself what I am going to do these next weeks. So my plan is to... we already know what the latency is going to do to the plugin in terms of synchronization. Next, I think I will try to tackle the hard question, which is how do I do this inter-plugin communication using JUCE? I already know how to do it in JSFX. It's pretty straightforward. Now let's try to do it in JUCE, and it will be a big challenge. But that's the challenge for this week. And Fotis is going to do the design stuff, and Siwitz is going to create yet another amazing DAW-like kind of thing. With and even solve bugs along the way, like the voice allocation that is acting weird. So I think that about wraps up. Any last comments or questions that I may be missing? All right, so thank you all for joining me today, and thank you, Bo and Tail and everyone else who was watching. I see you again 2 weeks from now, which is the 27th. Is that all right? Oh, no, that's a Wednesday, so probably the 26th.
Yeah, 26th.
Yeah, we'll see if we'll do it on Tuesday or Wednesday, because it seems like we are all available on Wednesdays, and Arya wants to do some interviews on Tuesdays. But yeah, either the 26th or the 27th of April.
I'm okay with both.
Okay.
I'm also.
Okay. So we may be moving this to Wednesday permanently, but we'll see. All right. So thank you all, and I see you on the next one.
Thank you all. Bye.
Thank you.
Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And so we'll be back together for some more coding or talking or chilling. The next time I'll be streaming.